Well, dear students, this is Unit 3 and Session 3. In the previous session, I did explain the constant volume process. Let us remember and recollect some of the things which are needed to work out the problems regarding the constant volume process. Well, in case of constant volume process, as the name implies, there will be of no change in volume. That means what? The total work done by the system is equal to zero. All the energy supplied to the engine will be stored as a internal energy. Then heat supplied is equal to internal energy. The enthalpy is equal to what? MCP into change in temperature. Okay, these were the information were given to you in the previous session. That is session number 2. Now, let us look into the problems pertaining to this constant volume process. Well, see, here is a question. I would like to tell you, before working out the problem, you first make out the problem completely. Okay, this is the problem pertaining to the constant volume process. A certain gas occupies the space of 3 meter cube. It's the volume of the gas at the beginning at a pressure of 2 bar. Okay, in the previous classes, I did explain also 1 bar is equal to 1 into 10 to the power of 5 Newton per meter square, and a temperature of 77 degrees Celsius. Right. It is heated at constant volume until the pressure rises to 7 bar. Okay, after heating that gas, the pressure has been increased to 7 bars. Determine the temperature at the end of the process. Okay, beginning initial process is initial temperature is given. You have to find out the final temperature. A mass of the gas. Here, the mass is not given, but the volume is given. In that way, volume has to be converted into the mass. Change in internal energy. Assume CP. What is the CP? Specific heat at constant pressure and specific heat at the constant volume, and take R is equal to, that's a gas constant, 287 joules per kg Kelvin. Okay, these are all the datas given. Here, what I have written, those are the datas which were explained in the beginning itself. Here, as I told you, according to the SI units, if the temperature is given in Celsius, that has to be converted into the Kelvin. It's very simple. What the temperature is given over here, that should be added by 273. Then the total temperature becomes in Kelvin. So next is how this problem is worked out. Uh, As the implies here, you look into this, V is equal to constant. That means what? There will be of no changes in volume. From that general gas equation, if V has cancelled each other, the leftover is P1 by T1 is equal to P2 by T2. From this equation, we can calculate the final temperature. Here, T2 is the final temperature. It was defined in the beginning, data given. See, substitute the values of the P2 pressure, that is 7 bar, and initial temperature is 350 degree Kelvin, divided by P1 is 2 into 10 to the power of 5 Newton per meter square. Then you are getting the final temperature of the system after heated. It becomes the 1225 degree Kelvin. Okay, now the volume of the gas can easily converted by making use of this relation. This is one of the gas equations. What is equal to PV is equal to MRT. Here the initial one is the same, one and the same. P1 V1 is equal to mr T1. Simply you take m because mass is also remaining constant. The mass will not be changed. I think it is not asked to find out the final mass and all. Okay, after rearranging this, okay, here we know the initial pressure, the volume, we know the gas constant is given, but here you can calculate the gas constant also, and we know the initial temperature. To calculate that gas constant, this relation will be used. That gas constant is equal to Cp minus of Cv. Okay, that is equal to 0.293 kilojoules per kg Kelvin or 293 joules per kg Kelvin. Okay, it is obtained. Next, substituting the values to this equation, we are getting P1 V1 divided by R T1. After substituting, P1 is the initial pressure, uh, volume is the constant volume, 293 is the gas constant, 350 is the initial temperature in Kelvin. After the simplification of that, okay, the mass of the gas inside that container is 0.85 kgs. Now, it has been asked to calculate change in internal energy. See, while I was explaining the constant volume process. Okay, the what amount of the heat supplied that will be equal to the change in internal energy. That's what here du is the internal energy, that is m mass of the gas, Cv is the specific heat at constant volume, T2 minus T1 is the increase in temperature. You know all the values, you substitute. Okay, what is that? Mass is here we have found out 0.585. It is not 585, it's a 0.85. Here the point has to put and it has to be multiplied with the CV. There, that is, it has given CV, specific heat at the constant volume, and this is the change in temperature. After simplification of that, change in internal energy is equal to 364.455 kilojoules per kg. Next, it has been asked to find out change in enthalpy. Okay, this is the equation. Change in enthalpy dH is equal to mass of the gas in specific heat of the gas into change in temperature. Here, you know the mass of the gas is 0.585 kgs and specific heat at constant pressure is 1.005 and the change in temperature is same, that is a 1225 minus of 350. After simplification, the change in enthalpy is equal to 514, that is a 514.4 kilojoules per kg. Okay, this is how we can work out the problem regarding the constant volume process. Say one more problem is given. You may work this problem on your own. Okay, I'll read out. You may work out the problem on your own. The values of the specific heat at the constant pressure and at the constant volumes for the ideal gas are 0.984 kilojoules per kg Kelvin and 0.78 kilojoules per kg Kelvin. Find the values of the characteristic gas constant and the ratio of the specific heats for the gas. If 1 kg of this gas heated at the constant pressure from 25 degree to 200 degree Celsius, estimate the heat added, work done, and change in internal energy. Also calculate the pressure, final volume. Okay, this is the problem pertaining into the constant pressure process. Okay, for that reason, this problem will be worked out after finishing of the constant volume, constant pressure process. Sorry. See, with this information, I am concluding this session. Thank you.